Alright guys, we are back with part 2, and we're going to go ahead and get started with the next couple of examples. Graphing from a verbal description. Now I'm given an equation, and I need to model the relationship for this equation by writing it out, writing out an equation to determining what the slope is, what the y-intercept is, and the x-intercept. So let's read the problem. A linear function g models a relationship in which the dependent variable, that's an important key word there, so I'm going to highlight that, increases 3 units for every 1 unit the independent variable increases. Graph g when g of 0 equals 3. Identify the slope, y-intercept, and x-intercept. Well, let's start with the y-intercept first, because I have a piece of information here. It says, here we go, graph g when g of 0 is equal to 3. Now let's talk about function names. Remember, this means a function, and it's telling me the name of the function is g, and is giving me the x value. So let's look at this, g of x. And we know another way of writing g of x is y. So you can say that g of x is equal to y. Alright, now let's look here what we got. We got an x variable, an x value, and a y value. So we can take those two pieces of information and write an ordered pair, because this tells me that for this specific x, I have this specific y, or this specific input gives me this specific output. So if that's the case, then my y-intercept is 0, 3. Now we can go back to our slope, and here's the information that's very valuable. It said in which the dependent variable increases 3 units for every 1 unit the independent variable is. Well, this kind of gave us the slope already. It's telling us how the x values are changing and how the y values are changing. We remember that slope is the change of y over the change of x. Well, y is also known as our independent variable. I'm sorry. No, x is our independent variable. So let me write x up here. And y is our dependent variable. So this says our dependent variable, or the y, increases by 3 units. So think about that in terms of numbers. Let's say I started at 1. Then my next unit will be plus 3 because it's increasing by 3, if you remember the table that we did. So that means I have 3 over my change in x. Well, it says the change in x is it says the dependent variable increases 3 units for every 1 unit the independent variable increases. So my independent variable increases by 1 every time. Alright? So that means my slope is 3 over 1. Okay, now we can graph it. First we start with the y-intercept at 0, 3. And let's go back to the slope again. Just notate the words here. Sometimes words are very important. If it had said decreases, then this 3 would have been negative, because you want to decrease every time. And so in order to decrease, you will have to be negative. So the fact that this says increases lets me know that this must be a positive slope, or a positive, my y is positive, okay, in this case. Alright, so now it's the rise over 1, so it tells me to go up 3 and over 1. So I'm going to go up 3 and over 1. 1, 2, 3, and over to the right 1. 1, 2, 3, over to the right 1. When my trust is without borders. Alright, down 3, over to the left 1, because you got to go in both directions. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. And then take your ruler. I'm going to take my highlighter and draw you a line. I cannot draw a straight line. That's better. Okay. Now we need to find the x-intercept. Well, the x-intercept is the place where it crosses the x-axis. Okay? So if I look here on my graph, here's my x-axis. If I look across the x-axis, I see a dot. And this dot is at -1, 0. Okay? All right, let's go down to the next example before I start singing again. All right, example 4, application. So here's a real world problem. The population of the United States is projected to be 300 million by the year 2010. Between 2010 and 2050, the population is expected to increase by 2.5 million per year. Now, let's make a note here. Even back at the previous example, when we saw words like increase, decrease, independent, dependent variable, we always relating it to the slope. Okay, so this one will be no different. Okay, I have the increases by 2.5 million per year. It must mean it has something to do with how my y and my x change. And then if you're trying to figure out whether this is your, remember, slope is your change in y over your change in x. If you're trying to figure out whether this 2.5 million has something to do with the y or the x, well, just look at your axis, okay? You know your y-axis is horizontal, your x-axis, your y-axis is vertical, excuse me, and your x-axis is horizontal. If I was to read the graph, then I know that my y-axis is talking about population, and my x-axis is referring to years, because we know that years is always going to be your independent variable. So it says write an equation in slope-intercept form to find the population P in any year X between 2010 and 2050. So here it is again. It told me what X is. X is the year. Okay? So now I know that P is going to equal, okay, my slope, which has to be this 2.5 million per year. So that'll be 2.5 times x plus, now I have to figure out where it started from. Well, it started in 2010, and at 2010 the population was projected to be 300 million. So that's where you start from. Every year from 2010 on down will increase by 300 million people per year. Okay? Or you started at 300 and then it increases by that 2.5 million per year. Okay, if that makes sense. All right, now we need to graph it. And just like all our other word problems that we've established so far, now that I have an equation, you can make a XY table. Okay, X, Y. Maybe I should put that over some. Here we go. Okay, and then I want to use the values that's on my x-axis. I don't have to make up anything. I look at how they got a number here. They got 0, 20, and 40. These are the numbers that you're going to plug into your formula. All right, well, let's start with 0. That gives you your y-intercept. When x is 0, what is your output? Well, let's see. 2.5 times 0 plus 300. 2.5 times 0 is 0, and 0 plus 300 is just 300. Which we could have gotten it without even plugging in 0 because it is your b value. It's your y-intercept. So now I'm plugging it on a graph. At 0 is 300. Now, since this is in years, this represents 2010. So in 2010, we're at 300 million, I'm sorry, population-wise. And that's the beginning of our problem. That's what it stated. So we're on the right track. All right. Then at 2020, so I'll take the same formula. And for x, because it's my x, I plug in 20 plus 300. All right. So 2.5 times 20 is 50, and 50 plus 300 is 350 million. So at 20, my population rose to 350 million, which is somewhere in the center here. And then lastly, I'll put that in my table. Lastly, at 40, again, 2.5, x is now 40, so you plug in 40 for x. Plus 300, 2.5 times 40 is 100. And 100 plus 300 is 400 million people in the year 2040. And then once you have your dots, all of your dots on your graph, you can take your ruler. Please make sure you do this. Again, we are graphing lines. It is not a line unless you physically draw the line. Okay, take your ruler. There you go. Okay. I don't know what I did there. Let me just redo. There we go. Okay, so that about wraps it up. And hopefully you have enjoyed this tutorial. Please watch it again for stuff you might have missed or you need to hear again. And I will see you in class. All right. Bye.